This is the second video for section 10.5. We're going to look at intersecting lines and circles. If two lines intersect a circle, then there are three places where the lines can intersect. Here's the first place. They could intersect on the circle, where that green dot is. They could intersect inside the circle, or they could intersect outside the circle. We're going to look at one theorem in this video. That's going to be theorem 10.12. We're going to focus on the angles intersecting inside the circle theorem. So if you have two chords that intersect inside a circle, the measure of each angle is half of the sum of the measures of the arcs intercepted by the angle and its vertical angle. It sounds confusing. We'll just do a really quick example here. I'm going to say that angle 1 is 80 degrees. Its vertical angle is obviously 80 degrees also. Now that 80 is an average of the arc that corresponds to it and the arc that corresponds to its vertical angle. So if you had that blue arc and that magenta arc measure, you would add those together, divide by 2, and you would end up with that 80. That's what that means. Okay? Now, likewise, you can do the same thing with this angle. That's got to be 100 degrees. So its vertical angle is also 100 degrees. The arc that's made by that angle and by its vertical angle, if you add those up and divide by 2, if you average them, you would get that 100 degrees. That's all that means, theorem 10.12. So we're going to skip ahead to this slide where we can use theorem 10.12. I know I'm using that theorem because I have two chords that intersect inside the circle. They're going to give me two arc measures. I'm going to make one of them blue and one of them magenta. What's the measure of that angle that's formed? Now, we probably should have talked about this a second ago, but that angle is not a central angle. That red dot, that is not the center of the circle. If it was the center of the circle, then that x would match the measure of the arc. So that x would be 156 if that was the center. But it isn't the center necessarily. Okay? So what you're going to do is you're going to take that arc measure, that 156, and you're going to add it to the other arc measure of the vertical angle from that x, which would be the 130. And you're going to average them. So what number comes directly in between 156 and 30? That's what you're trying to figure out. Now make sure you're typing this in the calculator correctly. If you're doing it all as one operation, make sure you use parentheses. If you don't, it's going to give you some bogus answer that'll be bigger than both of them. Okay, the average is 143. And that makes sense because isn't 143 directly in between both of those measures? Okay, it's 13 degrees away from 130. It's 13 degrees away from 156. That's how you use theorem 10.12. We're going to skip ahead again to another example where you can use theorem 10.12. That'll be the first theorem on this slide. We want to figure out what the measure of that arc is. We know the measure of an angle where two chords cross. We know it's 102. If it helps, you can put your vertical angle on. Notice how we're not concerned with either of the arcs formed by those 102 degree angles. We're more concerned with this blue arc, that's y, and then this magenta arc that's 95 degrees. Use what you know about linear pairs. If two chords cross, that angle is going to be 78 degrees. Now remember, that 78 is the average of y and 95. Okay, so I'll say that again as we're writing it. Y and 95 together, when you add them and divide by 2, that has to give you 78. So the space is a little tight for me, and it probably is for you. We're going to multiply both sides by 2. What is 78 times 2? Be 156. And then we're going to take away 95. And that'll give you 61 for y. And you can double check your work. Is 78 the average of 61 and 95? And it is. That's how you use theorem 1012.